All right, we're graphing ratios using repeated subtraction now. So again, just like repeated addition was much like multiplication, repeated subtraction is going to be much like division. Let's see what they got.
The diameters of different circular objects are given in a ratio table. What do you notice about the graph of the pairs of values given in the ratio table?
What do you notice about the graph, right? So chances are they're going to go ahead and graph it, and then we'll talk about it. Right, so they put these data points onto a graph. So 7 comma 22 is right here, and then 14 comma 44 is right here, and then lastly 35 comma 110 is right there. Okay. The points that represent the values from the table are on the same line. Notice that they all line up on a nice straight line. Can you draw an object with a diameter of 10 inches and a circumference of 50 inches, right? So basically what they're asking us is, can we find a shape with those dimensions that would line up on this line? So here's our diameters, right? So if our diameter is 10, and here's 10, so I'm going to draw an imaginary line straight up to 10, and I can see that it's going to intersect this line right about there, and then draw an imaginary line over to the y value, and that's going to be 10, 20, 30, probably a little bit more than 30, but certainly not 50. So the answer to this would be no. Those ratios, that point, would not live on this same line. That point, 10 comma 50, would live right there, right? And since that is not on our line, it's not a similar shape. In other words, it's not a circle. Because if you hadn't noticed back here, these circles, right? These are all circles. So they all have the same ratio of the circumference to the diameter, right? 22 divided by 7 equals pi. The ratio of the circumference to a diameter is equal to pi. So all circles, no matter their size, if you carefully measure their circumference and diameter, divide the circumference by the diameter, you will get pi, which is approximately 3.14. And all of these are circular objects. The last one that we just did in the try it would not be a circular object. All right, so we're going to add in question number 13. Here we go, example 3. Same page, going to be 290, question 13. Page 290, number 13. Good luck. Any questions, make sure you ask. And if you want some tutoring, remember we have volunteer peer tutors available. Just let me know and we'll try to set it up for you. Good luck.